3xy squared minus 48x. How many terms are we dealing with there? 2, so it's really possible that you would have sum or difference problems again. But step 1 is common term. Is there a common term between 3 and 48? You can take a 3 out. Is there a common letter? Take an x out and not a y because they don't both have one. So what's left out of the 3xy squared? Just the y squared. And what's left out of the 48x? What? 16. And we close that. So how many terms do we have in here? 2. So what do we have to check for? Difference of squares or some difference of cubes. Is that difference of squares? Yes, this is a perfect square. 16 is a perfect square, and there is a minus in between them. So we must split that up. And what would that become then?
Y minus 4.
Right. So you just do the square root of both of those. So y minus 4 and y plus 4, and it doesn't matter the order. You can do y plus 4 first. So again, that's why you always got to check whenever you end up with a binomial and see if it works or not. We'll do an easy sum of cubes problem since we haven't done one of those before. X cubed plus 27. So it's the same as squares. You just got to figure out, is x cubed a perfect cube? X cubed a perfect cube? Yes. And then you've got to figure out the perfect cubes. Is 27 a perfect cube?
Yeah.
Yeah, 3 times 3 times 3 is 27. So you do have a sum, because you got plus in the middle, you have a sum of cubes. There is a pattern that you follow for both of these, and I'll show you the pattern. So if you have a cubed plus b cubed, that's what you started out with. And again, this is just a pattern that you'll follow, which is what we have. You have 2 perfect cubes with a plus in the middle. So you split, here's how you split that up. You will do the square root or the cube root of both of those. So the cube root of x cubed would be x, and what do we say the cube root of 27 is? I'm doing the pattern, sorry. So we'll look at this one, and then we will apply that to the problem we're working on. So what would the cube root of a cubed be? A plus, what? Cube root of b is b. This is also listed on 349 in that fairly handy table. So then you're going to have a trinomial following. And here's how you get it. You're going to square this first term, and what would that give you? A squared. Yeah, the next, then the sign with the sum is minus plus. To get this middle term, you're going to multiply these together, which would give you, you're going to have AB, and then plus, square this last one, and that would give you B squared. It's the same exact pattern for difference of cubes, except both of these are plus. That's the only difference between sum of cubes and difference of cubes. Just those signs right there are both plus.
So why is the middle one minus 80?
It's just a pattern.
So it's going to be minus every time.
Yes, with sum of cubes, which we got here, sum of cubes, it's always minus plus. Just remember that.
So it's minus plus minus.
If it's difference of cubes, then they're both plus. So let's apply this to the x cubed plus 27. We have our first set of parentheses there. What's the cube root of x cubed? We already said was x plus cube root of 27 is 3. So then we square this first term.
X squared.
That would give you x squared. And then minus, multiply these together. 3 times x is 3x. And then plus, and you square this last term. And that would give you 9. So that's how you split up the difference of cubes, or sum or difference of cubes. Here was the difference of squares problem. Those are obviously easier. You just do the square root of both, y minus 4 and y plus 4. If you have a sum or difference of cubes, this is what your answer will end up looking like. Do one of the difference of cubes. So we have x cubed there. Is 8 a perfect cube?
Yeah.
Yes, it is. And what's the sign in the middle? It's minus, so we will be doing difference of cubes this time. It's the same way. You're going to have one first set of parentheses with the binomial. So the cube root of x cubed is x minus cube root of 8 is 2. And then we've got our trinomial there. And what will our signs be in the middle of this one? Plus. So we square this term. It'll be x squared plus, multiply these two, 2x plus, square this last term, and that would be 4. It doesn't matter positive or negative because you already should know those are pluses no matter what. So those are the signs. You don't have to worry about the sign. The last new thing is a polynomial that has quadratic form. We've done problems like x squared plus 13x plus 36 d4. So you're still, when you see a problem similar to that in homework, you just go right back through the steps. So is there a common term there? Do they all three have an x? No, so there's no common term. So you go back to your steps. Would we even be looking at step 2 here? No, we have 3 terms. So we're going to just be checking to see if we can factor that trinomial. So that's what we are checking here. This is, again, review. Put your x's in there. What will our signs be? Again, you look at this one. What's this mean? Sum, same. So both of your signs are plus. So you need factors of what? 36 with a sum, or that add up to 13. So the factors of 36. 1 and 36. What else?
2 and 18.
2 and 18.
3 and 12.
3 and 12.
4 and 9.
4 and 9.
6 and
6 and 6. So any of those add up to 13.
4 and 9.
4 and 9. And that's it. That's what we are used to. We haven't done anything different. What they're going to throw at you today is x to the 4th plus 13x squared plus 36. What changed? The exponents, right? Right, so we got a 4 and now a 2 there in the middle. You do this problem exactly the same way, except, so we put our two parentheses, not a 2x, an x squared. Instead of just putting in x's, put in x squared. Everything else is exactly the same. Still put your pluses. Factors of 36 we've already found are 4 and none.
We don't have one of those as subtraction.
In here,
And then
where this is, where your signs are going to
Yeah.
be different. Yeah, we can probably find one. Yeah, let's see.
151 is the same key.
Let's do one more easier one. X to the 4 minus 29 x squared plus 100. So is there a common term?
X squared. Oh,
Not a common term. You jumped ahead. Not a common term. It is a trinomial. So we split it up, put our x squareds in, and our signs will both be what this time? Remember, it's same as the first, so both minus and factors of 100. 25 and 4. Is this problem done? How many terms do you have in each one of those parentheses? 2, so what should we be looking for? The sum or difference stuff. Is that difference? So this is difference of 2 perfect squares, so what would we split that up to be? X minus 5 and x plus 5. How about that other one? X minus 2 and x plus 2. One last thing before you start on your homework. Look at page 353 where your homework is. What are the instructions on 1 through 8, for instance, the first 2 words of your directions? Factor completely. So your answers will be left as factors. If this problem says to factor completely, this is your answer. Just leave your answers in factor form. But then look down at 11 and 12. What do the instructions tell you? Solve each equation. That means you're going to set all those factors equal to 0. And we're going to do a couple of those real quick. X to the 4 minus 34x squared x squared. Plus 49. Anytime they want you to solve, it'll be set equal to 0 already, like this one is. So how many terms do we have there? 3. Is there a common term? No. So we check to see if we can factor that as a trinomial. So we put our 2 in parentheses, factors of 49, that what? What? That equal 50. What are our signs? Both minus. Factors of 49 that will equal 50. 49 and 1, that's pretty simple. 49 and 1. Now, stop right there. Look back to the original problem. What's the highest degree that you see there? 4. So how many roots would you be looking for? 4. They don't have to be real. Last time we said that 4 was the maximum number of times it would cross if they were all real. They don't have to be real. So this tells you that there are 4 definite roots. They just may not all be real. In this case, they are. So we need to find those 4 real roots. And it's the same as the last problem. What would we split this up to be? X plus 7 and x minus 7. And the other one? X plus 1 and x minus 1. Now, most of you can see what's going to happen when you set all those equal to 0, and so you would just be able to write your answer out. I think we could probably all do that. What would we get for the 7s? 7 and negative 7. If you set both of those equal to 0, so we would say plus or minus 7 and plus or minus 1. How many numbers do we have listed there? We got 4. That's how many we should have. Plus or minus 7 and plus or minus 1. So positive and negative, obviously that counts as 2. Homework. We will do 2 through 10. No, 2 through 8. 12 through 22. 30 through 34. 'That'll be good. And that is on page 353. Again, this assignment and the 6-5 assignment from last time will be due on Wednesday.